I'm a software developer. I've been watching Kotlin for a few years, and I've been using it for the last year or so. To make it clear, I'm not affiliated with JetBrains. I'm just a Kotlin user, like maybe some of you. And also, as a disclaimer, this is introduction, so there won't be anything very advanced. Overall, the idea is that I will talk for a little bit, then will be quite a bit of like live coding, then we'll look at Kotlin puzzlers, and that's it. So feel free to interrupt me or ask questions at any point. I think I can repeat them in microphone, and then it will be fine. So everything I show is already uploaded to this link on Dropbox. So if you want to take a photo, so nobody's taking a photo. Yeah, one person. Yeah. So I assume everyone here knows what Java is, and of course the answer is it is an island. So zooming in on Google Maps, it's quite a big island really, and notice there is Java C at the top. So some photos from Java. It turns out there are really nice places there. I've never been, so. And now you obviously can guess what Kotlin is. Yes, and it is an island. Zooming in again. Not so far from here. It's like near St. Petersburg. What? Kotlin City. I wish. No, it's a small island. Looks something like this. So it's near St. Petersburg, and I guess the language is developed by JetBrains, which are like originally from St. Petersburg, but now more like spread farther. So in reality, this is a programming language. It's statically typed pragmatic language for JVM and JavaScript platform. So statically typed is hopefully self-explanatory. Pragmatic means it was designed and created for real-world use, so not experimental language like real features. Designed for good tooling, so that you can develop really good ID support, fast compilation type. So as it implies, it's designed for JVM and JavaScript. So it also compiles to JavaScript. So if you've been to previous session here, it's just like Scala.js. It's the same thing. It's also production ready. You can use it tomorrow. So it's open source project, Apache 2 license. It's mostly developed by JetBrains, but in theory, you could fork it and so on. So here is some analysis of how many commits over years they made. So as you can see, this is not very new language. It's like horizontal axis is time. So this is 2011, this is 2017. And vertical axis is how many commits per month were made. So you can see it's been developed since 2011. So it's not very new. The first release was about a year ago, 2016. And unlike JavaScript, for example, which was allegedly developed in 2 weeks, this was developed in 6 years. Right? And it was done deliberately, I think, and before the release, all the features which were not necessarily so great, features which were maybe a bit too experimental, they were removed, and it was a very conservative choice. And there was a recent release, Kotlin 1.1. So, like, obvious question, why not Java? And if you're happy with Java and you like it, then just use Java, right? So, but in reality, my favorite silly thing why Java is not good is because there are semicolons, and at last Java 1 there was a panel with architects, and there was a question, are there any plans to remove semicolons? And the answer was, like, technically it's possible, but realistically there are so many other things to do, it's not going to happen ever. So this is why Java is like very old-day language, and there are reasons this cannot evolve fast. So why not Scala? There is an argument Scala went too far already with language design, so it's difficult to write very good tools for it and so on. But again, if you're really happy with Scala, then like don't switch. Kotlin, in a way, is like conservative version of Scala without fancy features, like basic features. And why not Groovy? The argument is it doesn't have strong typing. It has optional types, but not strong types. So if you write very big project, it can be problematic. In addition, Kotlin has its own features which do not necessarily exist in other mainstream languages, for example, nullable types. And I'll mention coroutines, which not in every language, so I'll mention some of them later. And so this is like introduction. So basically, Kotlin is production ready. It's like better Java, less powerful than Scala, but more realistic language, and it has static types compared to Groovy. You can try it tomorrow. So this is like the whole gist of the talk. The rest is just detail. So I will do examples, and I'm doing examples because I think it's better for people to see how it actually works in IDE rather than some slides. So we start with hello world. the classic example, but it will be intense hello world. So what we have here is IntelliJ in presentation mode. And this is a main function like you would have in Java. So I'm going to run it now. And it prints hello world over here. Right. So here what we have fun is keyword. Very good choice for fun. Because you always have fun in Kotlin. So the main method is like cstyle. This is function name. It takes one parameter called args and it has type of array which strings. And this is return type unit. This is like void in Java and it's optional, so we don't need to mention here in curly braces. This is body of the method, then println, and it takes string literal. So here println, if I navigate to it, we end up in Kotlin IO. This is the package, so, and it calls Java system println. So this is basically like Java switched back. So this is hello world. What we can do, for example, extract this word into message. So now we have variable message which assigns literal string. As you might notice, this is string interpolation. So the actual, this is Java syntax. So you can do with curly braces, you can do with the showing thing, multi-line, string literal, and so on. I'll undo changing. Right. So you might notice there is type inference here because we don't specify type. But you can, like in Scala, you can say, oh, this is actually a string. And here, the interesting thing, this is like Kotlin string. So if we compile this, and you might see that at runtime becomes just normal Java length string. So if we look, for example, I'm using this action Kotlin bytecode. This is built-in thing into IntelliJ. So here we have signature for main, and what I select is the Java length string at runtime. So this is the trick why it works for all platforms. There is a core bit of Kotlin which compiles to both JavaScript or JVM bytecode. Also, you can put a Java length string, it will work fine. It's just that normally you would, all these types are Kotlin. So another thing you can do, try and do message, assign something, ID will complain that val cannot be reassigned. You can change it to var, just like in Scala. Then what we could do, change it back to val, extract, let's say, a function with greeting. And as you can see, this is a function like before. The only difference is that syntax slightly different, equals, and it returns a string. So this is another, this is single expression body. We can convert it to the syntax like above, like this. Unlike Scala and Groovy, in function you have to have return keyword. Maybe it will change in the future, but right now you have to do that. So again, we can try and say something, but then ID doesn't like it again. So we can try do var, but we cannot, because all arguments are forever values. So we cannot do this. One interesting feature which doesn't exist, like it comes from C# is extension method. So we can do this transformation, convert parameter to receiver. So what happens here is now syntax of this function is string dot, and here in hello we do hello print this. So basically like pretending that the first argument is actually the target object. So also in the println, it's message.greeting. You can do a bit more stuff with this, like fun, string, println, and then you can do println this. So you can switch println to the end. So I guess it's maybe natural for C# people. In Java world, this is slightly a different thing. You could achieve the same thing with Scala implicits, but it will be way more expensive. Because if we again look at bytecode for this code, all the extension methods, so here they are, like greeting, which is really public final static. So there is no polymorphism on this. So if we do, for example, greeting any, and any is like object in Java, then it's just not used, it's decided at compile time which method is used. It's like, in a way, it's less powerful. So what we can do, I'll switch this back to normal methods. We'll get the message. So you also can have default values. For example, default values. We can have names for arguments like this. Like seemingly small features became very useful. So to show some Java interrupt, here is static function from Java, and we can call println. Notice like works with extension methods straight away. You compile, so now it prints hello from Java. You can navigate into Java, and you can see it is Java because there is semicolon. Let's switch back. So functions can be defined anywhere. You can move a function into function. So fine, this is like the most private scope you can get inside some other function. Then you can have just private, like private for this file, and there is no package protected. And by default, everything is public. There is also internal, which is internal to this module of compilation, which is in Maven and so on. So this is like intense hello world. Anyone wants me to type in the code? Okay, yeah. No, that's code. So I can move this thing into here, and then extension method println exists only within this main. So they are scoped. And compared to Scala, because it's static, it just will be perform way better in terms of compilation. Okay, so I'll move on. This was hello world. It's what we looked at. Basic syntax, string abstraction, validus, var, named parameters, extension functions, and Java integration. So because it was so intense, here's a joke. So the question, what was first, egg or chicken? And from evolutionary point of view, there were animals which had eggs and they existed before chicken, so eggs come first, for sure. So this was hello world, and it was kind of about strings, right? So now we go to factorial, hello world for numbers. So this is I assume people know what factorial is. This is the wiki definition, just multiplies numbers. And here's some code, go into factorial. Again, presentation mode. So here we have function factorial defined inside main. It takes an int, it returns an int, and if n less than 1, it returns 1. Otherwise, we create factorial n minus 1 multiplied by n should make sense. So I'll transform it a little bit. I'll move it outside of main. And because if statement is expression in Kotlin, I can do this lift return out to if n repeats. So returns were here, and now they're returning from if. Then we can replace if with when, which is like case statement in Java, but more powerful. So here's the same condition, else we return factorial. But I don't like it here, so I'll just like convert it into one line. So this is 2017, so we should probably be writing unit tests. So notice there's different tests plural. This is the argument that all tools that assume that postfix should be test are wrong, because you have usually multiple tests inside the class. So if everything's wrong, this is correct. So, and we can calculate factorial. So you might notice here, test is just normal JUnit thing. This is just normal JUnit annotation. Then, like in Scala, we have backticks to specify any function name. And now I'll just move all printlns into there. So I will run this now from test to just print and see that anything comes out. So yeah, we have somewhat expected result, 111. So now I will write some assertions quickly. Let's say 1. I'll fix it later. Now the question what we want to import. Notice there is hemcrest with K, but I will use just standard Java ones to again show Java interop, which should work. So if I can run it again, it should fail, and then we can fix the result. But yeah, it seems to work. What is? Yeah, sorry. Okay, it works. So this is kind of okay, but you might guess, what if we try this? And we get here, we get a negative number, which is obviously not right. Factorial should be negative. So similar to strings, underneath this int, which is actually, if I control click on it, goes to Kotlin again. This again, it's abstraction over different platforms. And it's also compatible with Java, so you can use your Java ints, pass them around like you do in Groovy, for example. So unlike Scala, Scala maybe not so perfect integration with Java in Kotlin is really good. So this is basically lowercase int on JVM, so this is why it silently overflows. And one of the answers to this might be to use big decimal. Or big integer, but I'll use big decimal because less typing. And so you go and it's like, change this to big decimal 1. And a bit of changes here. Something like that should go. Yeah, it looks fine. So now we got the actual number here. So what you can notice here is that, for example, this is big decimal, and you can see from import it's just normal Java big decimal. It comes from Java math. And this is constructor, and it's called without new keyword because there are no new keywords in Kotlin. I think it's a very good decision. Just why would you want keywords everywhere? Like new. So I'll move factorial up a little bit. And here the interesting thing that we had to change integer literals to this constant 1. Would be nice though to write it something like this. And I guess like in Scala you would write implicit conversion. In Kotlin you could do like with extension methods. So I'll do one quickly like this. And it will be compared to, then we can wrap it into big decimal. So here we just wrote a compare to method which converts wraps int into big decimal. And the interesting thing is it has operator keyword, which is like for operator overloading in Kotlin. So if I remove operator, ID highlights this as red. You can do a similar thing, for example, for minus. So it will be minus. So the full syntax for it is something like this. Function call. The interesting thing when we looked at integers, they also were calling methods. So, and because there are no lowercase int, it's kind of unified type system. So unlike Java, there is no this weird thing for lowercase numbers. So this is like big decimal up to this point, but as you might guess, if I do something like this, factorial, and then big decimal, println, where we should be able to use big decimal, just using normal println. So that if we do something like this, like 30,000, so you might guess what's going to happen. It's a Stack Overflow exception because we exploded stack. And this is because factorial is recursive implementation. So the function calls itself and it just uses too much stack. There is tail rack annotation similar to Scala. So you have to specify it explicitly in Kotlin. And here ID complains that we marked it as tail recursive, but it's not actually a tail recursive function because the last thing is multiplication. That's the thing we do. So I can quickly rewrite it to tail recursive thing. And then the error should go away. So say this is that, and we'll just change results. Otherwise, we'll change results back on. Yeah, so now error is gone away because the last operation we do in the function is this. So there will be tail call optimization, and it will all work just fine. Hey, we got our tiny number. Scroll right. You see scroll, you can see scroll. That looks correct too. So just to drop something really confusing that this wasn't, there are support for coroutines since Kotlin 1.1. So if you want to boost your ego during an interview, you can mention like co-recursion. There is recursion and there is co-recursion. I heard about recursion for a long time. Turns out there is co-recursion. You can do something like this. So I'm not going to explain that this is like creating some sequence like stream in Java basically. If I specify type explicitly, this is the type. Notice that there is a while true loop. And all these yield and build sequence, they're not really keywords. This is just library function. So I'll stop here, and I guess I'll just move back to slides. This is what we looked at. It was int, lon, all numbers like object, no new keyword, operator overload, and tail-call optimization in unit test. So because it was intense, here's the joke. So what it means is like, unless you're in space, your glass is always technically full. So half air, half water. And the next example is a bit more enterprisey. It's data munging kata. So code kata in general. This code kata was written by Dave Thomas, who also wrote this book, Problematic Programming, a good book, a bit old, but good. And he wrote this website. It used to look a bit more serious than that. But in general, code kata is like an exercise which you repeat to get better at something. So in martial arts, they repeat the same movement. In programming, they repeat the same exercise. That's the idea. So he published a bunch of katas. There are other websites, but on this website there was a code kata with data munging, kata number 4. So switch to ID. Oh yeah, the kata is basically about data munging, which is like more enterprise theme. When you read a file, text file, you process it, find some data. So part 1, you process file with data about weather. And you find row for the day with minimum temperature spread. And then you print it. And then you do a similar thing for football. And then part 3, you do refactoring. So I'm not going to do all of it, but I'll do just a little bit to show how Kotlin works. So here what we have, I'll show quickly weather data. So this is the text file we're going to process. So like a typical enterprise, some stuff at the top, nobody knows what it means. Then you get some data. So here we have column with day, we have maximum temperature, minimum temperature, we want to find the row with minimum difference. Right, so I'll switch back, so this is what we have. If I run it, it should print this file. You might notice that it prints here, so the same content, and I'll hide it. And here you can see this is, again, I defined a class, then it's colon, this is how you extend a class here, and this is another testing framework, it's called Kotlin test. So I'll show other Kotlin tests. So slightly different syntax. Yeah, so here we have initialization, construction. So this runs after class is instantiated. Then we have a stream literal and some other stuff. So what's going on here, just to explain, this is the full syntax for it. So I'll make it very explicit. So this is lambda, and the syntax type for this lambda is this. So we define lambda, it has type which takes a unit, like void, and returns nothing. And this is how you define a lambda. So this is just some code. Right? And then we pass this lambda here. And this is invoke method we call on stream, because this is just stream literal. The interesting thing, this invoke, obviously Java doesn't define invoke. But if you control click on it, we see defined in this Kotlin test framework, it's extension method, and it's also an operator. So we can call it because it's an extension method. Because it's an operator, we can drop it, and invoke is basically just parents. And so this is it. And then, because lambda is the last argument which is passed to the function, like in Groovy or Scala, you can just drop parent and use syntax with lambda. So if I do like in line, then we can just drop parentheses. So this shows you, even though extension methods they seem kind of, oh, that's just static method, you can do quite interesting things with this. So what's going on here really? We have file, this is normal Java IO file, and we read lines from it. Read lines again, it's an extension method, and click on it. You can see this is in Kotlin IO, additional method. Read on lines into list, and then we call for each. You can guess like Scala Groovy if you know it, we get for each. Each is just like in Groovy. I will show the whole thing, the whole type for it. So this is the actual type. Say this is line. So this is lambda, which takes one argument, line of type string, and then it does print line. So if we call, because there is one argument, we can call it this. I think this is a really good name for default argument, better than underscore, because you can actually read. Like if you read literature, you never see like, and this was underscore something like that. No, it's an actual word. So this is good. So going back to like file read lines, you might notice there is no checked exception. Like we're not catching anything anyway because all exceptions in Kotlin are not checked. So just throws them. So and here just to unpack what's going on here, it's like again lines, and they have type of list and string. And here list, as you can guess, if I command click on it, we again go to Kotlin. This is an abstraction over Java and JavaScript. So here Kotlin at compile time again it will become just normal Java type. What you might notice, it's not a one-to-one mapping here because if I collapse everything, you might notice in this file there is list and mutable list. There is collection and mutable collection. So by default, all these interfaces, they kind of copy Java interfaces, but only read-only part. So all these interfaces in Kotlin, they're read-only. Read-only, though, doesn't mean they are persistent data structures. They're just like actually read-only. And you have to be explicit when if they're mutable or not. So this tiny, quick diagram. So the green bonds, they're read-only Kotlin interfaces, yellowish, orange, they're mutable, and some Java collections. So this was a bit maybe intense. So what we were doing, we were just trying to find a day with minimum temperature spread. And technically speaking, we've already done it because if you print the whole output, it will include the line with minimum temperature spread. This is cheating, so we will have to do more than that. The other thing, we can like use extension methods and just drop the first lines. Like if you remember, there was some rubbish at the top, so we can drop those 8 lines, and then we can take 30 lines. I just remember these numbers. So if I run it again, we should just consume the part that we need. So the header and the bottom is gone. Then we can. The idea is just to map them into some other data structure. So we can do it, split, regex. Regex, so split will, this is it in line, so we split each line based on spaces. So this is the output we get, so this is again list for each line, and these are the columns that we want, 1, 2, and 3. So notice here it's an object, so unlike Java, this was specifically designed to make sure you understand you're doing regex, not just some string, because Java will magically compile things in the background. So here we can do, for example, list of. It will be list 1, 2, 3. Here it's again overloaded operator get. So this is like normal collection get. These ones we want to do to int. This will be integer parse something. So if we run it, I think it might crash. Yeah, because there is some enterprise data, like these stars over here. So, I don't know what it means. So let's say replace typical enterprise development. Star with nothing. Just delete them. Yeah. So notice here we're doing list of, which is just as list in Java. And like some people might say, oh, why don't you use like tuples? Like there are tuples, but there are no triples. And there were tuples in Kotlin, and they were removed before the release just for those reasons that it wasn't clear if it's a very good feature or not. So the suggestion for now is like, not for now, but in general, it's a better idea to use something semantically rich like weather entry. So in this entry, it has day, which is a string. It has max temperature, which is int, and it has mean temperature, which is int. So we could use this weather entry here instead of this. So it's like sealed class, like case class. In Scala, it has similar like hash code equality, copy construct, and so on. So we can see now it's like the output with entries. So the next thing we might want to do is to find finally the minimum entry. So we can do min by it max minus it min, and then print it. Just print it for now. Right. I know the right answer. It would be nice to have 42, but only 30 rows in this file. So now we can write an insertion finally. So we can say this is entry. This entry should equal. This is built in into framework. Entry should be equal, and we can almost copy this thing. So, right. So now it should still pass and print things. So arguably we are asserting too much here because we were asked just about the day. So maybe it should be this, like entry.day, but ID is now not happy. And to understand why it's not happy, we should specify type here explicitly. The thing is that you now might notice there's question mark. We had just normal class, but now we have question mark, and this is because this type is nullable. So by default, Kotlin types, they cannot contain nulls at all. So if you wanted to say compiler, it can be null, you have to have question mark. So our options here, like if I do alt enter, you can surround with null check. And here it's interesting because Kotlin compiler can do smart casting because it knows this is final. Then when you check for null, then definitely here it's not nullable anymore. So other thing we can do ban, it means we guarantee it's not null. If it's null, throw null pointer at runtime. And arguably the last option is the best for the test, like question mark dot means if entry is null, the whole expression is null. So, and it will be just assertion null not equals 14. So there is a blog post by NetPrice about it. Nullable types. It's a good blog post, I recommend reading it. You can quickly look at pictures. So this is an actual like website, if I save it. So this is type hierarchy, you have any at the top like object. Then scrolling down, that's multiple inheritance from interfaces like in Java, single inheritance from classes. We have tomato, which can go in salad, I can be sun-dried, and it's a fruit, which is a class. Right? And then you have nullable type, which is basically we have this hierarchy. Now we have the same hierarchy, but with question marks. And here we have the thing when our non-question mark classes are subclasses of this question. So this was like the actual hierarchy is like mirrored here. Then there is a weird type, which we mentioned, which has only one value, which is unit, and like in Scala, you have nothing at the bottom of the hierarchy. So it's like one type system for all types and programmers. In a way, it's quite neat. So this is what we had here, entry. And well, we kind of almost did the part 1. I can quickly show what part 2 might look like. Part 2. So like similarly, there was like a file with football data and so on. So I format all of that. So again, reading lines, dropping, filtering, mapping, again, creating some class mean by something. So it's like pretty similar. And the third part might be interesting because if you try to extract an abstraction, it might be something like entry, well, key, any data class. Then if you try to extend it, you might bump into problems like putting, saying this is parent class of our entry. It's like, no, your class is final because all classes, this is another interesting feature of Kotlin. It's like all classes by default are final, so we kind of try to make it open, and it turns out that data is incompatible. So this is slightly useless now, so maybe it should be interface. And then maybe this value should be a property on interface. This should implement this, something like that. So hopefully it makes some sense, and in the end I could extract like another value which is called criteria, and the int, and then refactor common interface, and move to refactor. So there isn't much time left, so I'll just switch back to slides. Hopefully it showed you how like collections work in Kotlin. So this was hierarchy, this is what we looked at, collections, lambdas, data classes, nullable types, Kotlin. So like the final joke, this is how you do SQL injection on speed camera. So now, this was like the end of coding bit. Now we can move on to Kotlin puzzlers. Right? It's not fair to do puzzlers, assuming that some people don't even know the language. So it's more like pitfalls you can find when you just started learning. It's obviously inspired by Java puzzlers, but these puzzlers are not proper puzzlers. It's more like tiny events. So the first hello, hello, we have some code, like two functions, main1 and main2. So main1 prints hello1, and main2 is like equals parent. It's like Scala syntax hello2. Then we call them. What does it print? My reasoning, obviously hello1, hello2. Yes. Yes to the answer. So I go for B, so it prints both. Okay, you ready? So it actually prints just hello1. And the obvious thing is because there is no Scala syntax in Kotlin, the type of main2 just returns you a lambda. So main1 actually returns unit, main2 returns lambda. So don't try to type Scala syntax. This is what I am, what am I. So we have a variable value, what am I, it's like curly braces parent, and then it's printed. So my reason is that like curly braces, I don't know what, like probably it's a closure, right? And then we call it. And but what should it return? I don't know. Maybe it shouldn't be even legal. Right? So what are the answers? Now Kotlin unit doesn't print anything. It's weird. And I vote for D. I probably shouldn't compile. You have nothing. Anyone wants to go? Yeah, it's B. And this is because these are the actual types. Yeah, it's like lambda, which just returns unit, and this is the actual source code for unit. It's very concise. This is the actual unit in Kotlin. So yeah, just to show that this is just lambda. The next thing, it's my favorite, like return of power throw. So we have this function1, function2. Function1 returns an int, but it has like weird return thing. And function2 throws something twice. So my reasoning, because like lots of things, like everything, everything in Kotlin is an expression. So return 42 should have return type of int, and then we return int, so it's fine. And throw exception is not legal, because throw exception is like has some type like unit, and then throw unit is not okay because unit is not subtype of exception there. So what I vote for here, return 42 doesn't compile, so I vote for B. Anyone wants to go? And it just works. Everything works. The reason for it is because there is nothing at the bottom of the hierarchy. Actually, the return type of return 42 is not an int. The return type is nothing, and so nothing is subtype of int, so you can return nothing. And the same thing with throw exception. So, for example, there is a method in Kotlin to do, like in built-in library, throws not implemented error and has type nothing. So nothing is subtype of exception, so you can throw nothing. So it's never executed, but it's valid from compiler point of view. So you can write things like that. This is like fun return. This actually works. So what happens right return, like actually returns, and the left return does nothing. Or something like this. So now more complicated stuff, defaulted map. Like more involved code. So we have a variable n, and there is a map, and it has this dot with default n++. So think this dot with default, like in Groovy or Scala, it like grabs the existing map in another map. So when you have a when you request for a key which doesn't exist in this map, then it will kind of run this closure. And then we kind of print a line map with missing key twice. So my reasoning is that there is a map missing key. So missing key. So it should execute n++, but it will return 42 and upgrade n to 43. When we print it second time, it will hit again missing things. The question like, did it cache the result? I don't know. I guess no, because this is lambda like curly braces, so it should print 43 and update n to 42, 44. Right. So I go E 42, 43. So what is the answer? Yeah, so the trick is that obviously this is like operator overload, and this is just normal map get. And the interesting thing, what dot with default is doing, that's the question really. And with default is this grabs it into this interface, and as you can see, this interface doesn't do anything with get. It just adds something completely different. So yeah, this is the whole thing, and this is just a bug. Well, like was reported as a bug. It's like another feature. And they fix this issue, and this is how you actually write this code. Just don't use the other dot with default map because it's doing something else with delegates, like the feature I didn't mention. There are delegates like in C#. So this is how you write this code. This can be very confusing. Just don't fall into it. And the final one is 99 bottle. So if you would have package backticks 99, so it should be valid. Like although in Java you cannot use numbers as an identifier. So this shouldn't work. Then we have class bottles value bottles, and then we try to print 5. I think it should print 99 bottle. Why not? So I vote for A. Maybe it should be like underscore because it's not valid Java identifier. I don't know. So you want to guess? Doesn't compile. Compile explode. They bug really. This is not a fair puzzle. It's just compile explode. The whole point of this is like Kotlin is like ready for production, but it has more bugs than let's say Java C probably. So you're more likely to stumble into something in some corner case. So here it actually should work because if I move those classes inside main, then everything compiles. So this is like the lesson is that it is like nice language, I like it, but there are some problems and you can find it. So quickly Kotlin links. So let's go next. There is obviously homepage for Kotlin. Then you can run Kotlin code online. There is this exercises koans. So they will teach you like all the language features. You can do it in your browser. Kotlin koans also on GitHub. You can just clone them and do them. I do recommend them. It's pretty good introduction into language, like hands-on introduction. And then I did 99 problems in Kotlin. So if you know 99 problems in Scala, so maybe you can compare. There is a good site, kotlin.link. Once you get experience, you can find libraries and so on for Kotlin. So obviously, there is Twitter account for Kotlin, and there is Kotlin native kind. It's not kind, it's there already. There is also Kotlin blog. The good thing about blog, they have been maintaining it for all these years before the first release. So if you read the whole blog, you can see evolution of the ideas and how they removed features from language and so on. It's quite interesting. Also, there is Kotlin in Action book. This is a blog post about their book. And there is this site called discusskotlinlang.org, nice like a forum. And there is Slack, really nice Slack. I do recommend joining it for developers. They're very helpful people, nice place. And there is KotlinCon if you want to go and see the first ever KotlinCon. Hopefully I'll go. So this is the future of the Kotlin. There will be like more releases. Latest release, they're not as fast as they used to be, so I think like the JetBrains are fixing this. Then there are coroutines that have experimental status, but like very stable, just they don't want to commit to this particular design. They have to have freedom to say like, you know, we can change them and break backward compatibility, but they like actually work. An interesting thing what people will do with them from library point of view, how you can use coroutine. And there is Kotlin native, that's like experimental thing to compile Kotlin into binaries for different platforms. And it's pretty much it. The whole idea is go and try Kotlin. Thanks for watching. This thing shows 2 minutes. If you want to shout a question, I'll repeat it. Yeah.
It's a more comment, not a question. So you said that Kotlin is fun because a function starts with fun keyword, and I'm just sad to say that with coroutines there is a new keyword called suspend. So basically now with coroutines it's suspended fun. So yeah, not fun anymore.
The question was about interoperability with Java frameworks and Java in general. Most of the time it works really well. There are some, just you can pass in collections one-to-one. There is no wrapping like in Scala. So it's just like you can pass collections of values around. There are some frameworks which clash, for example, with function names and keywords in Kotlin, like when. It's keyword in Kotlin, so you have to backtick it all the time. So this kind of thing. So you need to like use inheritance, and this doesn't work in Kotlin. I mean, if you want framework, like mocking framework, so wants to subclass your Kotlin class, for example. But by default, everything is final. So you need to use additional theme in Kotlin, like all open, plugin for Maven, so that will remove finals for your mocking framework and so on. So in general, it works really well because it was designed for it, and it's used inside IntelliJ now. It's official language for writing IntelliJ. So the JetBrains they're using there, it's internal. So it is really good, but there are some rough edges of it. But it's definitely, it's actually like similar to Groovy experience. If you ever use Groovy with Java, it's very similar. Yes, well, it's like if you go to Kotlin homepage, like the website, you will see. I don't remember the guys. Kotlin is also big for Android. If they're targeting Android because they support JDK6 and it's like Basecamp guys are using it. Like they say, the Basecamp app is 100% Kotlin. They don't know Java. There's like one of those like cool guys on the internet. Obviously, actually, like bigger, more serious companies are using it. There was some framework for some finance. I don't remember what transaction. So you can find, yeah. I think adoption is like I've seen presentation by JetBrains people, and they show some exponential explosion of code in the last year and a half. Like I don't know, I haven't seen how they've changed the data. But in general, yes, it's growing. Hopefully, it will just grow and be bigger than Scala. Java. What was the con? Yeah. The comment was it's another Java cure. The more, the better. Okay, thanks. I think it's played, so it's best to go. Thanks again.